Okay, so I'm going to talk you through the solutions to the examples on the radical review sheet. So let's start with the first question. The question asks, if x is greater than 0, then what is the expression radical x times radical 2x equal to? And the reason we've got x is greater than 0 is because we do not know yet how to deal with square roots of negative numbers. But we will soon, but that's for next week. So let's just simplify this by multiplying the two radicands. We're going to have radical x times 2x, which is equal to the square root of 2x squared. And of course we can simplify this by taking the square root of x squared and bringing it outside the radical sign, and that would give us x times the square root of 2. And there's your answer to number 1. Question 2 asks us what the quotient will be if we divide the square root of 150 plus the square root of 75 by the square root of 3. The first thing we're going to do is we're going to simplify each of these radicals. I know that the square root of 150 is equal to the square root of 25 times 6. I know the square root of 75 is equal to the square root of 25 times 3. And that whole thing is still being divided by the square root of 3. Simplifying our first radical, I'm going to take the square root of 5, bring it outside the radical sign. Second radical, I'm going to take the square root of 25 again and bring that outside the radical sign. So I've got 5 radical 6 plus 5 radical 3 divided by radical 3. So what I'm going to do now to make my life easy is I'm going to factor out the square root of 3 out of each of these expressions in the numerator. So I've got 5 radical 3 times the square root of 2 plus 1 all over radical 3. And then I've got a factor of radical 3 in the numerator and the denominator, which is equal to 1, so I can eliminate them. And so my solution would be 5 times radical 2 plus 1. If you left your answer as 5 radical 2 plus 5, that would be fine as well. In question 3, we're first asked to find the product of these two conjugates, 3 plus radical 5 and 3 minus radical 5. For the purposes of illustration, I'm going to do the complete distribution, so that would be 3 times 3 minus radical 5 plus radical 5 times 3 minus radical 5, which would be equal to 9 minus 3 radical 5 plus 3 radical 5 minus radical 5 times minus radical 5, which is 5. And now I'm just going to simplify that a little. Here's some like terms. 9 minus 5 is 4, and then plus 3 radical 5 minus 3 radical 5 is 0, so the answer is 4. Now I just want to remind you that a minus b times a plus b is equal to a squared minus b squared. So in truth, you don't really need to do this whole distribution. If we have 3 plus radical 5 times 3 minus radical 5, a equals 3 and b equals radical 5, so we know that the product of those two is going to be 9 minus 5, or 4. So this is 3 squared, and this is radical 5 squared. The second part of question 3 asks for the product of 2 plus radical 4 times 5 minus radical 3, and I'm going to do this distribution again. So I'm going to have 2 times 5 minus radical 3 plus radical 4 times 5 minus radical 3. And here we go. That's going to give us 10 minus 2 radical 3 plus 5 radical 4 minus radical 12, which is equal to, let's simplify this. Well, I should have noticed that radical 4 is 2. So let's just simplify this a little further. This is going to be 5 times 2, which is 10. And radical 12, I'm going to simplify to 2 radical 3. And now let's just combine some more like terms. So I've got minus 2 radical 3, minus 2 radical 3. 10 plus 10 is 20 minus 4 radical 3. And maybe you were smarter than me and you noticed at the very beginning that 2 plus radical 4 is really the same as 2 plus 2, which is 4. So the problem was really just 4 times 5 minus radical 3, which is, and that would give you, again, 20 minus 4 radical 3. Perfectly acceptable and actually a little cleaner way to do the problem. Either way is good. In number 4, we're asked to rationalize the denominator of 2 plus radical 3 over 2 minus radical 3, because you know we can't have radicals in our denominator. And the way we do that is multiply the top and bottom of our expression by the conjugate of the denominator. Conjugate meaning we just change this sign to the opposite. So I'm going to simplify this by distributing the numerator over distributing the 2 factors in the numerator. And remember what we just talked about, that my denominator, when I multiply by the conjugate, the answer is going to be a squared minus b squared. Well, a is 2, so that's going to give me 4. B is radical 3, so b squared will be 3. And a squared minus b squared will be 4 minus 3, or 1, which is going to be nice. So here we go. Let's start multiplying. We've got 4 plus 2 radical 3, plus another 2 radical 3. Radical 3 times radical 3 is 3. And since this is equal to 1, I don't have to rewrite it. Let's combine some like terms. We've got 4 and 3 is 7, and then 2 radical 3 plus 2 radical 3 is 4 radical 3, and there is our solution. Number 5 is very similar. We have to rationalize that denominator again, so we're multiplying top and bottom by the conjugate, 2 plus radical 3. So in the numerator I'm going to get 14 plus 7 radical 3. And in my denominator, I'm going to get a squared minus b squared, which is going to be 4 minus 3, which is equal to 1. So my answer would be 14 plus 7 radical 3. Number 6, we've got a radical equation. We want to always isolate our radical first. So I'm going to divide both sides by 2 because I've got this coefficient of 2 in front of the radical. And that's going to give me x over 2 equals 2x minus 3. Then the square root of 2x minus 3. Sorry. Then I'm going to square both sides of my equation. And I will get x squared over 4 equals 2x minus 3. Now I don't particularly like having this denominator, so I'm going to multiply both sides of my equation by 4. And that will give me x squared equals 8x minus 12. And I see that I can get a quadratic here. I've got a quadratic here. So I want to get everything over to one side of the equal sign. So it's equal to 0. So I'm going to subtract 8x, add 12, and I will get x squared minus 8x plus 12 equals 0. And now this is a quadratic. I know how to factor. And I'm going to factor that up here. I'm going to get x minus 6 times x minus 2 equals 0. So x minus 6 equals 0, x equals 6. And x minus 2 equals 0, so x equals 2. And now we've got to, of course, check both of those solutions. So let's rewrite our original equation. X equals 2 times the square root of 2x minus 3. So for 6, we've got 6 equals 2 times the square root of 12 minus 3, which is 6 equals 2 radical 9, or 6 equals 2 times 3, which is indeed true. So x equals 6 is a solution. Now for x equals 2, I'll get 2 equals 2 times the square root of 4 minus 3, or 2 times 2. 2 equals 2 radical 1, or 2 equals 2. And so we've got two solutions for this equation, x equals 6 and x equals 2.